So now these are the steps for adding and subtracting fractions. First thing you want to do, and this little picture kind of shows you what you're supposed to do here. So the first thing you need to do is determine, are your denominators the same? You need to have like denominators when you add and subtract. It's like trying to add apples and apples. If you have apples and oranges, you don't put them together and call them apple oranges. You have to find something that they have in common, change it to that, and then you can combine them together. So if you have 5 apples and 3 oranges, you don't make it 8 apple oranges. You would make it 8 fruit, for example, something like that. Find something they have in common, and then you can combine them. That's the whole point of a common denominator, and that's what's needed when you're adding and subtracting. I am even going to back up one thing right here and say, just like we do with multiplying and dividing, check if you have mixed numbers first and change your mixed numbers to improper fractions. You don't have to do that when you add and subtract like you do with multiplying and dividing, but just to keep it simpler, we'll just stick with that. That'll be our method no matter what we're doing, because it always works for everything. All right, then if your denominators are the same, then you would move down here and you just add your numerators up. You keep the denominator because it kind of becomes like a label then. So like 3 apples plus 2 apples would just be 5 apples. So you just keep your denominator and then you reduce it at the end if you can. If you don't have common denominators, then you're moving over here and you have to find it first. There's a couple different ways to do that. In my opinion, that's the most difficult and challenging step of this whole process. So I'm going to show you a couple different things that you could do, and then you'll have a choice. Whichever way works better for you, you can choose whichever way. And then from there, you're going to multiply your numerators to make them match the denominators that you just found, and then continue the process. We go down, back down here, add your numerators, reduce if you can. So I'm going to go through a couple guided practice problems here before we move on to the word problems to make sure that this is clear. So, let me write it down first. It's 1/3 plus 3/4. Okay. Okay, so my first check off is I do not have any mixed numbers to worry about. I just have regular fractions. So then my second step is to check the denominators. My denominators are 3 and 4, so they're not the same. That means I need to get a common denominator first. Anytime I have to do that, I like to bring my fractions down and stack them like this, and that way I have room to write and do all the changing that I need next to it. For visual people, this is helpful. If you're not as strong of a visual learner, then you probably don't really care, but I like to do it this way. So now here's one method for finding the common denominator that we can use. We're looking for the least common denominator. So the smallest number that the denominators have in common. One thing you can do is just to multiply them together. That'll always give you a common denominator, but it won't always give you the least common denominator. The least common denominator is what you're shooting for, but the common denominator is what you need to have. When their denominators are consecutive, like what we have here, 3 and 4, or one is one right after the other. When you have consecutive denominators, always multiply them together. So 3 times 4 is 12. And I'm going to make them both 12s then. Okay, so here's my steps so far. All I did was multiply these two denominators together to make a common denominator, and then I can proceed with the rest of my steps. Okay, so the next step tells us we need to multiply these together, or we need to multiply these out, I guess I should say, and make the numerators match. So what that means is we need to figure out what do we multiply 3 by to make a 12, and then do the same thing to the numerator. So you can't just bring the 1 over, you need to make it equivalent. And then we do the same thing for the other one. We multiplied the 4 by 3 to make it 12, so we're going to multiply the 3 by 3 to keep your fraction equivalent. Okay, now if that's still not clear about what we're doing, just real quick, if I go back the other way, let's say I was trying to reduce these, you have to divide them both by the same thing. 4 divided by 4 is 1, 12 divided by 4 is 3. That's why you have to do it. You've got to keep these fractions equivalent. If you had just carried the 1 over, instead of multiplying it by 4, 1/12, you've now just changed your fraction. It's not 1/3 anymore. It's now a new fraction, and you are not allowed to do that. Okay, so there we go. So now I've got common denominators. I've changed my numerators to match, so now my fractions are equivalent. Now the next step is to add the numerators. So I'm going to add up the 4 and a 9 and keep the denominator. So here's my answer so far. You've got to wait till the end to simplify this time. You can't do it in the middle of the work like you can with multiplying and dividing. So here's my answer, and then I just need to see if I can reduce this at all. As an improper fraction, this is reduced. This is okay. As a mixed number, if I wanted to change it back, I would divide it, which is just a little bit of review from last week. Numerator divided by denominator, so denominator is on the outside. 12 goes into 13 once, which is 12, and you're going to have 1 left over. So this is your whole number right here, whatever number is in the top in the quotient. The remainder, if you have it, which we do in this case, there's your numerator, and the denominator stays. So my final answer is either of these two. It doesn't have to be one or the other. It could be either one. Okay, let's look at the next one then. Okay, so it's 2 and 8/9 minus 1/3. I'm going to go ahead and stack these from the beginning because I see that they are not common denominators, so that I can go ahead and get started. All right. So here is a case where you do have mixed numbers. So I'm going to change this 2 and 8/9 to an improper fractions first by looping this around. Multiply. 9 times 2 is 18. And then add. 18 plus 8 is 26 over 9. And then minus 1/3. So I'm just going to actually just scoot this over. Here we go. Now, next step is check your denominators. You have a 9 and a 3, so you do not have a common denominator. But here's a case now where a different method might work better. So I'm going to write it, I'm going to jot it down and then I'll explain it. what I said was, if one of your denominators is a factor of the other, meaning 3 here is a factor of 9, because you can divide 9 by 3. So 3 goes into 9 evenly. If one of these is a factor of the other, choose the larger denominator as your common denominator. It'll always work that way. So if you're looking at, for example, 5 and 25, since 5 goes into 25, choose 25 for your denominator. If you're looking at, let's say, 10 and 40, 10 goes into 40 evenly, so your denominator would be 40. If you're looking at 7 and 14, 14 would be the common denominator. Anytime one divides the other, pick the larger of the two. It'll always work. That's another method. All right, so going back to this, now, I didn't actually make a change to this 9 right here. It stayed the same. So it is essentially like multiplying by 1, which means that this 26 will be multiplied by 1 as well. There's no need to change that one. You only change the numerators that have their denominators changed. This one here, 3 times 3 would give us 9. So I'm going to do the same thing to this numerator. This one does require a change then. So 1 times 3 is 3. Now I have equivalent fractions with common denominators. Now watch out. We were subtracting from the beginning here, so I need to subtract 26 minus 3 is 23. Keep the denominator, and then reduce it at the end if you can. One more note about reducing. It can be improper or a mixed number in this case. The problem is I can't get this any smaller. So this is a reduced improper fraction, just like the last one was. The only thing I could do is convert it back to a mixed number. So 9 would go into 23 2 times, because 2 times 9 is 18. And when I subtract, I'll get a remainder of 5. So the answer would either be 23 over 9 or 2 and 5/9. Okay, and that one's done. Any questions? Can you guys hear me okay? It's telling me my device has got poor audio.
I can hear you.
I can hear you fine.
Okay, good. That's good. All right. So if there's no questions, then let's continue. I'm not going to do all of these. I'm going to pick 2 of them. So let's pick number 4 because it's a bit longer, and then we'll pick one of the mixed number ones too. Okay, so we need 3/4 and 3/5 and 3/20. We're subtracting and adding. All right, as a side note, don't forget the order of operations is always in effect. So when you have more than one, make sure you remember what to do first, second, third, and so on. Since you're just adding and subtracting, we have to go left to right in this one. So we'll add first, then we'll subtract. All right, so here is where we're going to start. You don't have any mixed numbers, so we're going to start with trying to find a common denominator for 4, 5, and 20. So pulling in the second note that I mentioned before will help us get this quickly. If one denominator is a factor of the other, choose the larger. And what I notice when I look at this is 4 is a factor of 20, and so is 5. Because 20 divided by 5 is 4, and 20 divided by 4 is 5. So they kind of all go together. That means I can use 20 as the denominator for all of them. Okay, again, I can divide 5 into 20 evenly, and I can divide 4 into 20 evenly. So 20 will work for all of this. And now I just have to figure out what my numerators will be. So I multiplied the 4 times 5 to make the 20 in the first one. So I'm going to do 3 times 5. And make that fraction equivalent. Then I'm going to look at this one here. I multiplied the 5 times 4. So I'm going to do 3 times 4. That one's equivalent now. And then the last one, I didn't do anything to it, technically. But if you want to write something, we're multiplying it by 1. So 3 times 1 basically just shifts that over. Okay, now it's all set up. Common denominators for everything, equivalent fractions for all my numerators. Now I can just go ahead and do my operations. So we're adding first. 15 plus 12 is 27. And then the 27 minus the 3 is 24. Keep your denominator and then see if you can reduce this. This one does reduce. Even though it's improper, you can still reduce it. So you're looking for something that you can divide them both by. You can divide them both by 2 and by 4. Since 4 is the biggest, I'm going to go with that. Because that'll make my work a little bit faster. So 24 divided by 4 is 6. And 20 divided by 4 is 5. So here's my reduced improper fraction. And then, just like we've been doing, we could also change this to mixed number form. Since it's improper, we can convert it to a mixed number. 5 would go into 6 once, with a remainder of 1. So, final answer would be either 6 over 5 or 1 and 1/5. We pause there for a second. Okay. I think we'll pick out number 6. Before we move on. So 5 2/3 minus 4 1/2. Okay, so let's deal with the mixed numbers first. We need to convert them by looping them around. So it's going to be 3 times 5, which is 15, plus 2 is 17 over 3. And 4 1/2 is 2 times 4, which is 8, plus 1 is 9. Okay, mixed numbers are taken care of. Next, check your denominators. You do not have a common denominator, but you have 2 consecutive numbers. So the easier thing to do in this one now is to go back for this first one. Multiply these together. So 3 times 2 is 6. So there's my common denominator. Okay, next step. We got to make the numerators match what we just done. So 3 times 2 gave us 6 for the first one, so 17 needs to be multiplied by 2, which is 34. And here, it was 2 times 3, so it's going to be 9 times 3, and that's 27. Okay, we've got common denominators and equivalent numerators. Now we're going to do the operation. So we were subtracting in this one. I'm going to subtract 34 minus 27, which is 7. Keep my denominator, and then try to reduce. This doesn't reduce any further, so we can convert it instead. 6 will go into 7 once. 1 times 6 is 6. Remainder of 1. So 1 whole thing and 1 left over. Okay. Questions, anyone? Okay. So before we talk about the word columns, I just want to finish up my thought over here. It didn't come up in any problems, but there's a few other things you can do if you're stuck trying to find a common denominator. So let's say we were looking for the least common denominator of just making this up. Let's say it was 6 and 9. As I said before, this first method, by multiplying them together, will work for everything. You won't always get the least common denominator by doing that, though. So that's the kind of the catch. 6 times 9 is 54, and it would work. However, there's one that's much, much, much smaller than that, which makes your work a lot easier. Instead of using 54, we could use something very small, and that'll make the work in the problem a lot easier. So here's another thing you can do. This is the third thing. There's actually more than this, but I'm not gonna give you every single thing that ever is possible. Just make a list of multiples. Here's what I mean by that. Multiples are when you count by a number. You multiply the number times 1, times 2, times 3. You just count by the number. So the first couple multiples for 6 would be 6, 12, 18, 24, and that keeps going. Multiples, the list of multiples will never end. Just make a list of a few and see what happens. For 9, multiples of 9 start with 9, then 18, then 27, 36, and that keeps going. And then once you have a list, you can see the least common denominator, or the least common multiple, is actually 18, not 54. So if you use that, your work would be a lot easier because you'd be working with smaller numbers. The point is, it doesn't matter if you find the smallest, just find one that works. So 18 is the smallest, but 54 would have worked, or 36 would have worked, or a whole bunch more after that too. Just find one that they have in common, so at least you can get the whole process started. The difference will be what happens at the end. If you find the smallest one, you'll have less work to reduce. If you don't, you just have to reduce a little bit more and you're done. Okay, that wraps up what I wanted to say about that. Let's talk about some of the word problems now. Okay, again, I'm just going to pick a few of these out for the practice sake. The more we do the word problems, the easier they will start to become, hopefully. So here, let's do number one. Steak costs $6 per pound. How much would 3.5 pounds of steak cost? So they're telling us it's $6 per pound for 1 pound. Now we're buying 3.5. That would be multiplication then. If it's 6 for 1, then we need to multiply the $6 times however many we're buying. So this is going to look like 6 times 3.5. We haven't done multiplication today. We did this last week, so let's review this. If you have mixed numbers, you need to convert those first. So this is going to become 2 times 3 is 6, plus 1 is 7 over 2. And for any whole numbers that you have, you just put those over 1. So now we're set up. When you're multiplying, you're allowed to reduce before you go. You can't do that for adding and subtracting or dividing, actually even, but you can do it for multiplying. So I do see something that reduces right here. This is when I'm allowed to do it, when I'm multiplying. So I'm going to divide these both by 2. So 6 divided by 2 is 3. And 2 divided by 2 is 1. Next, I go straight across. So numerator times numerator. Denominator times denominator. I'm going to, excuse me, reduce it if I can. And that's done. Okay, let's look at number 2. Let's get 2 parts here. Okay, so Jose loses 2.5 pounds every month for a year. How much did he lose that year? So he's losing 2.5 pounds for, if it's every month for a year, he's losing it for 12 months. So this is another case, just like the last one, where we have to multiply this together to see how much he lost all in total. So 2.5 times 12. Convert this one first. So this is going to be 5 over 2. And the 12 is a whole number, so it's going to be 12 over 1. Then I can cancel the 12 with the 2 since I'm multiplying.
32.
So this is now a 1, and this is now a 6. And then go straight across. 5 times 6 is 30. 1 times 1 is 1. So he lost 30 pounds. All right, let's look at part B. If you weighed 230 and 3/4 pounds at the beginning of the year, how much did he weigh at the end? So he started out at 230 and 3/4. How much does he weigh now? So if he started with this and then lost 30 pounds, since he lost it, we can subtract. Now here's the thing with this one. This is not going to work every time, but I want to point out to you guys what I see to save you some work in the future if you're able to see it as well. When we have a whole number here that we're subtracting, and we don't have to borrow, you don't even have to deal with your fraction. 230 minus 30 is just 200. So we can just subtract the whole number part and bring the fraction down. That would not work if we had to borrow. But since we don't have to, we don't have to worry about it. If we did have to borrow, we'd have to convert this to a proper fraction, put this over 1, find a common denominator, and do all of that work. In a case like this, though, there's no need to do all that. Here's your final answer. Any questions about that before I keep going? Welcome, Aisha. Welcome. Okay, no questions? Okay, let's look at number 3. So a nurse needs 2 3/4. That's supposed to say ounces. 2 3/4 ounces of medicine for one patient and 4 1/3 ounces for another. How many ounces does the nurse need for both? So what is the total amount of medicine? That means, let's add. Okay, so first thing, you have mixed numbers. We're going to convert them first. So 4 times 2 is 8, plus 3 is 11. Next one, 3 times 4 is 12, plus 1 is 13. And now the mixed numbers are gone. Next, check your denominators. They do not match. So we need a common denominator. Since they're consecutive, choose the first thing that I said and just multiply them together. And then we need to convert the numerators to match. So this is times 3. This is times 3. This is times 4. So this is times 4. Okay, now we're adding. So now that our denominators match and our numerators are equivalent, we add the numerators. So let's see, 5, and that's an 8. And that one's essentially done. Something else will simplify that. Oops. But we could convert this. So let's do that last step. 85 divided by 12. 12 will go into 85 7 times. because 7 times 12 is 84, with 1 left over. Okay, so it's either this answer or it would be 7 and 1/12. Ounces. Chances are you're going to measure it out the second way. So it's important that when you're talking about word problems, it's important that you're able to do both of these processes, because depending on what you're doing, one of them makes more sense in real life than the other. Okay, any questions about any of that? Okay. All right, I think we'll do just one more. Let's do number 4. Okay, John is making shelves for his room. He has 3 shelves, and each of them require 8 2/3 feet. How many feet of lumber does he need? So he's making 3 shelves. They're each 8 2/3 feet long. So how many feet of lumber does he need? We're making 3 shelves. Each of them is this long. So 8 2/3, then another 8 2/3, and then another 8 2/3 for people who need to visualize this. These are the 3 shelves he's going to hang on his wall. So it's 8 2/3 times 3. All right. Convert your mixed number first. So 3 times 8 is 24, plus 2 is 26, over 3. Put your whole number over 1. Check your diagonals and anything else you see that simplifies. Since the 3's are the same, they cancel out. It's like dividing them both by 3. 3 divided by 3 is 1. 3 divided by 3 is 1. And then just go straight across. So 26 times 1 is 26. 1 times 1 is 1. So he's going to need to buy 26 feet. He wants 3 shelves. Then for part B, if lumber costs $7 per foot, how much will he have to pay to do this? So that's a pretty simple calculation. It's $7 per foot, so that's $7 for 1. And we're buying 26 of them, so we just need to multiply this together. So 7 times 26 feet. Plug that in real quick. 7 times 26 is 182. That is very expensive lumber. But there you go. I'm going to just take a quick look and see what the other problems are before we stop. I think we've pretty much done all of this here. Yep, just more multiplication ones. So do we have any questions for me right now?